Today we're doing the Mentos and Soda experiment. It's normally done with Diet Cola, but I'm using Diet Sprite, and you can use any carbonated, unopened bottle of soda or seltzer for this, and it should work. I'll talk about why that is a little bit later on and why some people prefer Diet Cola. But the idea here is to get these Mentos into this soda. And we want to make it so that they all drop in more or less all at once, or at least as close to that as we can get. So to do that, I have this paper tube. It's just a rolled up piece of paper that's as big as my soda bottle's opening. And you can use a PVC pipe, a cardboard tube, foil. They even make plastic tubes specifically for this project. So what I'm doing here is I have my tube and I have another piece of paper here. It's going to act like my trap door. And I'm going to load my Mentos in to my tube. And then when I get outside, I'm going to unscrew the cap of this soda. I'm going to put my tube over the opening. And then when I'm ready, I'm going to pull that trapdoor out and let all the Mentos fall into my soda. Okay, ready to try it? We're outside now. Got my goggles on. Okay. I'm loading my Mentos. Position it over my bottle lid there. All right, and go. As you can see, that made a very big mess, so this is why you had to do it outside. For a really cool effect, you can use tonic water, which glows under black light. So if you have a space to do it at night when it's dark, you can go outside and do that with your bottle of tonic water and shine a black light on it and get some cool effects. So there we go. You may have seen this demonstration before, but what's actually happening? It's not a chemical reaction, but a physical one. When soda makers want to carbonate soda, they inject carbon dioxide into the bottles of soda under pressure. This creates what's called a supersaturated solution, meaning there is more of the solute, in this case the carbon dioxide, dissolved in the solution, in this case the soda, than there would be under normal conditions. The bubbles that you get when you drink soda are not actually present in the bottle until you open it. When the bottle is under pressure, the carbon dioxide stays dissolved in the solution. When you open the bottle, the carbon dioxide tries to escape the solution, and it does so in the form of bubbles, which are just carbon dioxide gas. Like crystals, there are two ways that bubbles can form. The first is called homogeneous nucleation, which is when bubbles are formed by the particles of the carbon dioxide interacting with each other. The energy cost for this is very high, and we say that this reaction is not spontaneous because that energy barrier is insurmountable and will not happen, or at least is extremely unlikely to happen, if left to its own devices. The other way that bubbles can form is called heterogeneous nucleation, which is when they form around something that has been given to them as a starting point. This could be another bubble, a rough surface, or a scratch in the side of the glassware or the plastic bottle. What we are doing with the Mentos is kickstarting this because we're dropping the Mentos into the soda, and the Mentos are not smooth. If you look at them under a microscope, you will see that they have millions of tiny depressions. These depressions are too small for the soda to get in and fully wet. So when they're being dropped into the soda, they're bringing with them millions of these little tiny air pockets, which form gas-liquid interfaces. The carbon dioxide that's trying to escape the solution will interact with these gas-liquid interfaces that are present along the surface of the Mento, and they will form bubbles there. And with the Mentos, we are able to form a lot more bubbles in a lot shorter amount of time than we normally would just by opening the bottle of soda. The number of these bubbles is what gives us this explosion, because they're all trying to get out of the narrow neck of the soda bottle at the same time, and they can't all fit. So they're pushing past each other, and they're causing this great exploding foam. Theoretically, the same thing would happen if you dropped a piece of sand or another kind of crystal or some bubble or rough surface into the soda. But it's not as impressive because the Mentos provide millions of these sites. So I said at the beginning that you needed an unopened bottle to do this with. And I'm going to demonstrate with this just plain glass of the same soda why that is. So first of all, if you put a straw into your soda, you can see that bubbles start to form around the straw. And that's because the straw is providing that nucleation site. So let's see what happens if we drop a Mento into this plain glass of soda rather than being an unopened bottle. As you can see, not very much. That's because this soda was not under pressure when we dropped that Mento in. The fact that this is a physical reaction and not a chemical reaction is why you can use any carbonated beverage or liquid. It's usually done with Diet Coke, but you can do it with any kind of soda, as I've shown here with Diet Sprite, and you can also do it with tonic water, seltzer, or any other kind of soda. The reason that people prefer diet sodas is twofold. The first is that diet soda makes a lot less sticky of a mess to clean up. The other is that scientists have found that certain components of the diet sodas, including preservatives and some of the artificial sweeteners, may improve surface tension, and that will give your resulting foam a better quality and perhaps a higher spout. However, there's no reason that you can't do this with regular Coke, Sprite, Pepsi, seltzer, or any other carbonated beverage as long as it is in an unopened bottle that is under pressure. Spicy. Spicy Mentos.
Anything else you want to say while we're out here?